We are from Group 5 and we are going to brief about semiconductor. So first of all, what is semiconductor? Semiconductor is a substance that has specific electrical properties that enable to serve as a foundation for computers and other electronic devices. Semiconductor sits between a conductor and insulator. It can be a conductor when a certain amount of external voltage being applied. So here we're going to take a look what material that is used for semiconductor. We have silicon, germanium and gallium. So first material is silicon. Silicon is the second most abundant element on Earth after oxygen. Most silicon is found in soil and rock, but silicon is also contained in natural water, trees, and plants. Silicon has 4 valence electrons and melts at a higher temperature than germanium. Silicon is widely used for making a semiconductor. Next, we have germanium. Germanium was one of the earliest semiconductor materials used. Germanium has 4 valence electrons, which are electrons located on the outer shell of the atom. The number of valence electrons in a semiconductor material determines its conductivity. And last material is gallium. Gallium arsenide is the second most common semiconductor is used today. Unlike silicon and germanium, gallium arsenide is a compound, not an element, and is made by combining gallium with its 3 valence electron with arsenide, which has 5 valence electrons.
Next, I will proceed with semiconductor development processes. Before this, I have talked about silicon, the main material which is used to make semiconductors. In order for silicon to turn into semiconductor chip, it needs to go through the manufacturing processes of wafer manufacturing, oxidation, photolithography, etching, deposition and ion implantation, metal wiring, electric die setting, and lastly is packaging. Moving on to the first step, which is wafer manufacturing. Is a process where the monocrystalline ingots manufactured by CZ process go through 4 carefully controlled steps to become polished wafer. This process includes 4 steps, which are slicing, lapping, etching, and polishing. Oxidation is where oxygen or water vapor is sprayed on a wafer surface to form a uniform oxide film. This oxide film protects the wafer surface during following processes and also block current leakage between the circuits and act as strong protective shield. Photolithography is process of draw a circuit design onto a wafer. A photomask help creates a circuit pattern on a wafer by using light-sensitive material and design glass pattern. Etching is the process of making patterns that form of semiconductor structure by removing parts of other than the necessary circuit patterns. Deposition and ion implantation. Doping with ion implantation is an essential step in semiconductor fabrication process. Through this method, atoms are intentionally introduced to silicon wafer with impurities that allow induction, while ion implantation is turning the wafer into a semiconductor. Metal wiring is a process that allows electricity to flow by depositing a thin metal film using materials such as aluminium, titanium, or tungsten, so the electricity can pass through the semiconductor very well. And electric die sorting is carried out by making the wafer come in contact with a probe card. Countless tiny pins on the probe card come in contact with the wafer and send electrical signals through it, and these signals allow defective chips to be sorted out. And after all, the last step is packaging. The wafer is cut into individual chips and then dies or sort chips based on the PCB board. In bonding step, the contact points of semiconductor chip based on the substrate is connected with the contact points of the substrate. Then the molding finishes the chip package to its desired shape. Lastly, after sealing the semiconductor and labeling the product name, the semiconductor chip is completed.
I will explain about how economy can be affected on semiconductor. Definitions.
Within the complex global ecosystem that is the semiconductor industry, shift in the economy can have a broad effect on pricing, innovation, production levels, and market competitiveness. Cost of effected, consumers' demand, global supply chain restrictions, investment in R&D, currency exchange rate, capital expenditure, global demand and production shift, labor cost and availability, government policy and incentive. Consumer demands is influenced by economic expansion or contractions. Demand for semiconductor depend on electronic gadgets. Global supply chain restrictions, economic experience like trade war, tariffs, or international instability can sabotage the semiconductor industry worldwide supply chain. Investment in R&D, amount of money invested in R&D by the semiconductor sector may be different depending on the state of the economy. Next is currency exchange rate. The cost of importing and exporting semiconductor materials can be impacted by fluctuation in currency exchange rates. Next is capital expenditure. Production of semiconductors require a lot of capital. Economic downturns may cause business to less spend on capital projects. Global demand and production shift. The global semiconductor market is subject to fluctuation in economic conditions in key markets such as US, China, or Europe. Next is labor cost and availability. Impact by economic conditions. Companies may reduce employment or wages during economic downturns. Lastly is government policy and incentive. Government policy and incentive improving the semiconductor industry can be influenced by the state of the economy.
Hi, I'm Ainur. Semiconductor production affect environment. Firstly, it's about climate impacts of semiconductor productions. Definition: climate change is creating many life-threatening disruptions, including extreme weather, rising sea levels, and droughts. This is about Infineon Company plans to reduce greenhouse gas emission by 70% by 2025 compared with its 2019. Next is Intel Company recently committed to net zero greenhouse gas emission in its global operations by 2040 and has targeted achieving 100%. Next, what is manufacture semiconductor fab? It's a manufacturing plant in which raw silicon wafers are turned into the integrated circuit. Next, the list of semiconductor fabrication plants. First is integrated circuit, next is integrated device manufacturers. For example, Samsung. The emissions which represents the highest proportions of GHG from semiconductor companies are linked to the energy required to run their extensive production facilities. This is the graph of carbon dioxide's equivalent emissions for a typical fab profile. Based on the graph, Scope 1 significantly add for CAP's GHG emissions profile arise from the processed gases used during wafer etching, chamber cleaning, and other tasks. Next is Scope 1. Emissions may also arise from high GWP heat transfer fluids that may leak into the atmosphere. Lastly, the critical levers for emissions improvement. First is decreasing energy consumption. Next is optimizing energy supply and reducing processed gas emission. That's all. Thank you.